So, while testing network on chip, so we have got certain issues to be considered. First of all, instead of providing a test access mechanism separately in terms of timelines and test buses, so it will be better if we can reuse the on chip network, because if we can reuse it, then these extra timelines are not necessary. And while we are designing a NOC based system, so the customer is anyway paying for this extra interfacing that we are putting, these routers and links that we are putting into the system. So, they are paying for that, but in fact what they should pay for is the functionality of the system, the functions or the features that this system has. So, as a result, so those are seen as overhead from the designer or customer's angle. So, if we can save something at the at the testing point, so it is better. So, instead of putting separate test access mechanism, so it is better that we try to reuse the infrastructure that is already existing in the NOC. So, reusing on chip network for testing, so this is one of the important features. Then we have to do test scheduling. So, scheduling has to be done just like the SOC testing. So, we said at which time which core is going to be tested. So, here also same thing, we have to talk in terms of the time at which individual cores will be tested. Now, you see that this may lead to some test resource conflict, in the sense that if we have got an NOC where say one mesh based NOC where we have got these. So, suppose this is a 4 by 4 NOC where at the junctions we have got the routers, and say with the routers the cores are attached. So, here one core is attached. Now, with this similarly for with other routers the cores are attached. Now, suppose with this router some core is attached and we want to test that core. Now, how can we test it? So, the ATE that we have in the system, so ATE will communicate to one of these cores. So, normally what is done is that ATE channel is connected to one of these core as input point, and similarly ATE channel is connected to another core as the output point. So, this is the this is input towards ATE and this is output from the this is input from the ATE and this is output to the ATE, and this ATE is interfaced to have to talk with these cores, and these cores, so in the test mode, so they will transfer the test pattern to this router to be destined to the to this core under test, and similarly the core under test. So, it will send the response to this core from where it will be transferred to ATE. Now, while doing this, so assuming that it follows an XY routing policy, so during the entire test session, so these resources are all busy, all these resources are busy. So, if suppose this ATE has got multiple channels, so there is another channel that uses this core as source and the core attached here as source, and the core this is another source, and say this is another sink. So, that way the input is fed to this core and output is collected from this core. For so, two parallel checking testing can go on, like one test can do this. Now, if another test is say testing say this core, then or say it is testing say this code, then it is possible, because the test patterns can go like this, it can go this through this channel reach here, and the response can be sent like this to this channel. So, that way these paths are non overlapping. So, for the two channels, the paths that are coming for transferring the test pattern and response, they are non overlapping in nature. So, if they are overlapping, then naturally the two test sessions cannot go on parallelly. So, this scheduling is important. So, scheduling will tell us like for what at what time we can do the testing, and the resources that are needed for testing in terms of this intermediate routers and links, they must be available for this entire test session. So, this scheduling has to be done carefully. Then this test access methods and test interface. So, how are you going to use the test, in the sense that whether it is going to as I was telling in this example, that we assume that this core and this core. So, these two are acting as source and sink. Similarly, these two cores are acting as source and sink. So, like that we have assumed. So, that is the access mechanism for the testing. Okay. So, and the interface, like how this interface is there, like individual cores that are attached, so they must have their wrappers and all that. So, this test access method and test interface, so they will be talking about that. Then efficient reuse of the network. So, we have to identify potential parallelism that can be achieved by doing this scheduling of testing of various cores to by different ATE channels. So, we have to do some efficient reuse of the network. Power hour and thermal hour testing. So, these are two important issues that we have seen. Since in a NOC, so it is more regular in nature. So, we should be able to do justice to the power and thermal issues. So, though many of them are same as the SOC testing, but here we have got the added overhead in terms of these routers to be tested, then these links to be tested and all that. So, this is the extra thing that has to be done. So, which was not present in SOC, where the TAM lines might be tested initially by some flash patterns, but here we need to test these individual routers and links separately. So, that actually adds to some overhead. So, if to go to the network on chip, so assuming that the current design methodology is a system on chip based design. So, we have got CPU, memory, embedded RAM, IP, hardcore, then this self test control. So, all these modules are there and there is user defined logic. So, interconnection scheme is like this. So, shared bus. So, there are buses maybe core A and core C are put on first bus and core B and core D they are put on another bus. So, that may be the shared bus architecture. Now, you can have dedicated connection like say these cores. So, they are point to point connection. So, core A needs to talk to B and C, as a result it has interconnection to B and C. Similarly, B needs to talk to C, so it has got connection. C needs to talk to A and D, so it has got connection to A and D. So, this way we can have some point to point type of connection, but as we have discussed, this point to point connection is going to be costly. Because large number of interconnect lines need to run, and this shared bus is costly because the performance will be at a premium. So, performance will suffer when we are connecting more number of cores to a bus. So, this need for network on chip. So, the design community, so the communication infrastructure is becoming the new bottleneck. So, individual cores they are made more and more they are made faster and faster. So, they are actually operating at a much higher frequency, they can produce data at a very high rate, but this needs to be transferred to the destination, and this transferring, so that becomes a problem. So, if we assume a pure serial communication between two nodes, then this serial communication takes time. Now, we go for parallel communication. So, parallel links, number of lines that will pass is a problem. So, routing of all those lines is a problem. Now, apart from that, this compared to a serial communication. So, when we have got this parallel communication, so this parallel communication is faster because you can transfer multiple bits simultaneously, but this also has got limitation because we cannot transfer data at a very high rate because of the crosstalk between these between the parallel lines, and if one of the line makes a transition at a high frequency, so it affects the values that are there, the logic values that are there on the adjacent lines. So, this is known as aggressors and victim type of situation. So, that way this signal delay becomes a problem. So, communication infrastructure is becoming the new bottleneck. Wire delay, so that is one issue, that delay from source to destination. Serial communication is out of question. If we have point to point parallel connection, then also this establishing connection between all the cores, so that takes a lot of wire delays. Then signal integrity. Signal integrity means due to, as I was telling, that due to transition in one line, so the other line may be in some other line value may be changed. Maybe this line is constantly at logic 1, but this line makes a transition to low. When it makes a transition to low, so due to capacitive and inductive coupling between these lines, so this line also maybe for some time it will show a glitch, and it will be something like this. Now, if this glitch is if this voltage level drops significantly, then there is a possibility that at the receiving end we are sampling the line at this time, as a result we get a wrong logic value read, or if this if there is a positive glitch. So, this line is making a transition from low to high. As a result, this line may also makes a transition, it shows a glitch and then it comes back. Then this glitch, the peak value, that will tell whether this can cause any harm, and also the duration of the glitch, that is also another issue. So, those that way the signal integrity may be in question. So, that has to be addressed. Power dissipation. So, power dissipation of this bus and this interconnect, so they are going to be high. So, we need some regular way to handle this interconnection. Area versus speed. So, area is definitely the area in terms of this bus. So, we can do it on by running a single bus. So, as a result, the area requirement is low, but speed will also be low. We can have multiple buses. So, that way this area requirement goes high, but speed also goes high. And finally, so if we are going for some other mechanism, so we have to we can try to have a better trade off between area and speed. So, new interconnection schemes are needed. So, for testing purpose, so this is for the design side. For the testing side, so test of SOC, so that is well understood. So, we have seen how it can be done, like the TAM design, the wrapper design, then the test scheduling problem, and the IEEE 1500 standard. So, that has told the standard interface of these core wrappers. So, that way this testing part, SOC testing is understood, but in case of NOC testing or this network, networked environment, so we need some dedicated hardware. So, the test will require some dedicated hardware, and hardware for mission mode communication cannot be reused for testing. So, the hardware that is used for communication between the modules when they are doing the function, so they cannot be used for testing purpose as far as the SOC is concerned. So, we need some solution to that. So, in a NOC based system, as far as testing is concerned, so what is done? So, as I was telling, so this is a SOC implemented as an NOC, where these boxes are the routers. So, we have got these cores, and between them these green boxes, they are actually the network interface. So, what is this? So, this particular router network, it will follow some networking protocol, it will have some packet length, it will have some packet structure and all that, maybe in terms of start bit, stop bit, packet size, header, trailer and all that. So, for every communication has to be demarcated by those special symbols. So, the message that this core generates to be transmitted, so this needs to be divided into packets which can be transmitted over the network. So, this packetization has to be done, and in the packetization process the proper formatting has to be done. Then second thing is that this at the receiving end. So, this is at the sending end. At the receiving end, these packets are to be combined together and give a message has to be formulated, and that message has to be delivered to the destination core. So, these green boxes, so they are known as network interface or NI in short. So, they are actually doing this packetization and depacketization of messages into packets and vice versa. So, what happens is that whatever communication is going from this core, it goes to the corresponding NI, and this NI converts it into a format which is acceptable to the underlying network. So, through the underlying network, the packets traverse to the destination, and at the destination they are combined again to get back the message and delivered to the destination core. Now, from the tester, as I was telling, there may be multiple channels, like say the tester may decide that okay, so it will feed test pattern via two cores. So, this one and this one, maybe these cores are equipped with some special feature by which it can accept input from the tester. Basically, the cores which have got interface to the system pins, so they are dedicated for this purpose, because of through that we can access individual cores, and they can be put in some sort of bypass mode, so that these test patterns that are transferred will be given to the NI to be transmitted to the destination. So, some modification has to be done, some extra logic has to be added with the core, so that this tester can be interfaced with these cores. So, they are sending the patterns, and these test patterns are from this point it will be it will be sent to the destination using the underlying network. NOC based system. So, they are actually the possible next generation SOC paradigm, which is known as network on chip. From the design angle, so high performance and because of high bandwidth and low signal delay. High bandwidth, effectively the bandwidth increases, because in an NOC what happens is that several communications can go on simultaneously, unlike SOC, say bus based SOC, so where only one communication can go on through the bus at a time. In case of NOC, there can be multiple communications going on parallelly throughout the NOC. As a result, the effective bandwidth increases. Signal delay is low, because these individual links are much shorter. So, if you look into a mesh type of structure, then between the links are running between the successive routers only, and these links are of some fixed length. So, as a result, this requires some fixed amount of time to traverse through the link, unlike say one SOC where there may be it may be put onto a bus, or it may be a one to one connection, point to point connection, but that connection length, the length of the wire may be too large. So, those problems are there. So, that way the frequency of operation gets restricted. So, in case of NOC based system, so the high performance can be achieved by this high bandwidth, effective high bandwidth, and the low signal delay between the successive stages. It is overhead in most of the cases, it is reasonable, in the sense that these routers that we have, so routers are made very small, so that they support just a basic routing type algorithm, and so that the overhead is the router overhead is much low compared to the core. So, it may be 0.1% or 0.01% of the total SOC area may be dedicated for the network part, including the routers, network interface, and the links. So, it is suitable for large number of cores. So, that is another point, because for less number of cores, maybe we can do with point to point connection or bus based connection. So, they do not cause any harm. However, when we have got a large number of cores, so taking to SOC is difficult, because the communication between them becomes a problem. So, NOC based system can do better communication. So, we can have we can take help of this many parallel communication that may occur in the among these cores. Okay. So, if you have large number of cores, possibility of this parallel communication is more. As a result, we can exploit the NOC infrastructure for sending a large amount of information from sources to destinations. Network design is versatile, because that is the design has to be versatile, it should be common for any design, and it is the methodology for next generation VLSI design. So, that is what is coming up. So, we have started getting designs around NOC, and industries they are doing the designs. From the test angle, test of NOC has not received that much attention like the this test of this design part that uses NOC. Okay. So, the challenges are again increased. So, test engineers are again at a negative side, or a uncomfortable side, because now the job of this testing process, so it has increased the amount of job to be done. Core testing, so it was there in SOC design, so it is there in the NOC design as well. So, the test data volume, test transfer time, so those things are not going to reduce. Apart from that, we need to test the routers and interconnect. So, this is the additional thing that has come up, because all the test patterns will be transported through the network. So, if the router or interconnect is faulty, then these test patterns cannot be transported. So, core testing does not have any meaning if we do not perform this router and interconnection testing. And for the correct operation of the system, this router and interconnect, so they must be working properly. So, even if not for the sake of transporting test patterns, so we need to ensure that this router and interconnection network, so that is they are all working fine. So, that has to be done. Test wrapper design definitely there, because we have to we have to do this, we have to wrap all the cores, so that this NOC channel width, like between the routers, the links that are running. So, links are not of arbitrary size, like unlike say this TAM based design, where maybe I have got 64 bit TAM, w equal to 64, and there we had some trade off. So we gave different amount of timelines to individual codes and tried to see what is the corresponding test time. But in this case what happens is that, say this is one router and this is another router, so between them we have got a link. So this link has got, so this is a router, this is a router, and this is a link. Now this link has got a particular size, maybe this link is say 32 bit, or link is say 64 bit or 128 bit. So like that link may have some number of bits in it. So this w, I do not have any option. So I cannot give less number of bits to be transferred in the to this code. So this code that I have, so code this local channel that is there, so that is also of size this 32, 64 or 128. So this core, it gets input 32 bit input, 64 bit input or 128 bit input, the other options do not exist. So that has to be done. So that has to be taken care of by means of this wrapper design that we have here. So if I have, if this core has got more number of inputs than the channel that is connecting it, so the wrapper has to take care of it, and it has to it has to connect, it has to do the wrapper design part, so that the interface becomes 64 bit only. So that way, depending upon this link width, we have to see like how many bits we can how many bits we have for the TAM. So we can do this test wrapper design, so which is now more specific, unlike SOC where it was more flexible. We could have generated different we could have allocated different test TAM width and see different types of wrappers. Here that is not the situation. Then the test scheduling, so this problem remains. So anyway we have to do the test scheduling. So at which time which core is going to be tested, or which router is going to be tested, and how the test patterns are going to be transported to the core or the router. So that way the scheduling has to be done. On the plus side, we have no need for dedicated TAM. So because the underlying network itself will be used for transporting the test patterns and responses, so there is no need for dedicated TAM, and a network can be reused for testing. The network that we have, the underlying network in the NOC, that we can use for testing purpose as well. So this is a typical situation. So this is a particular SOC D695 from the ITC 02 benchmark suite. So it has got some 10 cores in it. So cores are numbered as 1, 2, 3, 4 up to 10. Now suppose a particular NOC based realization of this D695 system is like this, that is no core is attached to first two routers, third router has got core 1 attached to it, fourth router has got core 5 attached to it. So this way we have got a 4x3 mesh network to which these 10 cores have been attached. Now we are trying to address how can we test this test this entire NOC. Okay. So from the designer's angle, from the designer side, so they have decided on how this routing will take place. Okay. So those these routers have been populated with the routing algorithms, and then what to do, how to do the communication, the packet structure and all that. So it is assumed that this particular design is a packet switching network that has been realized. So every packet may go through different paths. Okay. So every packet may go through different paths. So the switching is at the packet level. Then it is a bidirectional channel, every channel is bidirectional. So wherever we have got a connection from left to right, there is a connection from right to left. It is a 2-dimensional mesh, and the routing algorithm followed is XY routing. So XY routing means first the communication will go in the X direction, then it will go in the Y direction. So if there is a communication from say 5 to 8, core 5 to core 8, so core 5 will give the packet to this router, and this router, finding that the destination is 8, it will go in the X direction first and reach the column where this core 8 is located, and then it will go in the Y direction. So first it goes in the X direction, then it goes in the y direction, and so so that is why it is called XY routing. So XY routing has got many advantage. It is deadlock free, then it is the shortest path and all that. So those features are there. Now for the testing purpose, these channels and routers, they are to be used as test access mechanism, whereas this input output ports associated with the codes, and they are input output ports they are associated with codes. So this say from the ATE, the test patterns will come. So core 3 acts as one input point and corresponding output point is say core 4, and core 9 acts as one input point and core 7 is the corresponding output point. So we have got these test patterns to be transported from the ATE. So it comes to this input, okay, say core 3. Now if it is for say testing core number 2, then it will come to this router. So it will follow the XY routing. So it will come, it will proceed to this router, and then it will go in this direction. So the test pattern will reach core 2. So core 2, the patterns will be applied, and the responses from the core are to be transferred to the output. So again it is transferred to this router, and it is destined to core number 4 now, because core number 4 is the corresponding output port. So it is sent to this router. From here it comes to this router, knowing that the destination is core 4. So then it goes to core 4, and that is connected to the output. So this way this XY routing will be utilized for transporting test patterns and responses between the cores, between this input core to the core under test to the output. So you can see that we can do parallel testing, because one part. So for this entire operation, the routers that were needed were this one, this one, then this router, and again for response. So it was, so only these 4 routers were utilized, and these links were utilized for doing the testing. So at that time, if we were say trying to test core number 8 through the other channel, so that is very much possible, because from 9 we can send the test pattern. So it will come to this router to here, it will be delivered to this core 8, and from the core 8 the response will be again loaded into this router, and that will be destined to core 7 via this router, and that will connect to the output of the ATE. So this way the two testings can go on parallelly, two test sessions can go on parallelly. So here it is assumed that it is a non preemptive path, because the test, once it starts, it does not stop in between. So it completes, and then only this it can go to another test session. So each core has got an associated routing path from input to that core, and from that core to the output. All resources are reserved until the test is completed. Unlike say the design unlike the functional mode of operation of the NOC, where since the switching is done at the packet level, so once a packet has been transferred, so it is not mandatory that the remaining packets will also go in the same direction. So resource reservation is not needed. But in this case, while since we are thinking about non preemptive testing, so test patterns will be applied, all the test patterns for a core will be applied in one shot. So they will be forming a non preemptive test set. So we have to keep all these resources reserved till the test ends. So test pipeline can be maintained, because once these test patterns are going through this routers, so the test patterns can be sent in a pipeline fashion. So since it individual routers, they introduce something called an wormhole routing. So where a packet traverses through the network in a serial fashion. So as the buffers are becoming free in successive routers, so the remaining part of the packet will be drawn from the previous router. So that way, at any point of time, you can find that a test packet is distributed over a number of routers buffers in the path. So anyway, so that gives rise to pipelining. So we can send all these packets in a pipelined fashion from the source to destination. No complex logic is required, because this is a simple transfer, and this routing is already implemented by the functional operation. So, in the functional operation of the NOC, the routing is already implemented. So, no complex logic is necessary. So, it is similar to circuit switching, because in circuit switching we know that the at the beginning of this message transfer, the circuit gets established, and for the then the entire message goes through that circuit only. So, similarly here also the same thing is happening. So, we have got this source and destination, between which the test packets are going in a in an ordered fashion, and there is no interruption in between. So, we need to efficiently assign IOs and channels to the core. So, that is very important one to be addressed.